Hello guys, welcome to Modern Physics. I'll be starting electron and motion of electron in electric field. So let's say we have two plates like this, positive and negative in upper and lower places respectively, and the distance of one plate is a big D and the distance between the plates is small d. Now, let's say an electron starts in the middle point, let's say right here, an electron, and it has an initial velocity of u, and then it enters into the electric field. Now, the positive plate attracts the electron, so uh, it goes like this, right? And then after the electric field, it goes tangential like that. So here, this is the projected path if there was no electric field. Now, from this figure, if the electron moves in a horizontal distance before entering into the electric field, then the initial well the initial velocity across x component, let's just say this is x component, is u, horizontal component, and uy is equals to 0. Now after it reaches into the electric field, it gains an acceleration directly above, because well the positive plate is in the upper surface, right? So that means that the forward acceleration is 0 and the upper acceleration is a. Now from here, if the force experienced by an electric field is equals to the the force of the electron is equals to the experienced by it by the electric field, then F is equals to Fe, or mass into acceleration is equals to, well, that is EE. If you remember in electrostatics, we need both the knowledge of electrostatics here and the also projectile motion here. So here, or ma equals to, well, E is just the potential difference V by distance across between the plates. So therefore acceleration equals to EV by md. Now let's just take any point, let's just say P right here, and let's just say it is at a distance x from, well, this point, and at a distance y like this, and let's say it took time t to get there. So here we can use s equals to ut plus half at square. Now for the horizontal component, we have x equals to ut plus this whole thing is 0, because, well, acceleration across the horizontal component is 0. Therefore we have time equals to x by u. So now let's take the vertical component. So vertical, this becomes y equals to, well, initial velocity u, uy is 0, so this is 0 plus half at square. Now this becomes half. You can use the acceleration as ev by md into time square, which is x square by u square, and we can write y equals to kx square, where k is 1 by 2 ev by md u square. We need this to show that, well, the motion of electron in electric field is parabolic, because this is an equation of a parabola. So this is a very much required for numericals. Y equals to 1/2 of ev by md into x square by u square. And also a numerical tip is that if the question states that it just grazes the top of the electric field, that means just grazes means just touches, then y will be equals to distance by 2, because if this is the whole distance, then that means this between from the midway is distance by 2. Now let's just say another point at point q, at which it just escapes the electric field, thus it gains a velocity v, but it will also have a horizontal velocity and a vertical velocity vx dy respectively, and let's say this angle is beta, right? So now let's just say it took time t dash to reach from start to the end. So here, using, well, velocity equals to distance by time, we have initial velocity u equals to the distance between one plate by t dash, right? So that means time dash is equals to distance by initial velocity, because it took the initial velocity to get to that point. Then we also have the, well, we have v, vx and vy. We want to find out what is vx and what is vy. So now we have first one component vx, which is, well, we can use u plus at. We have v equals to u plus at, right? And here this is just equals to u because acceleration is 0, and vy is equals to 0 plus acceleration into time dash, because again initial velocity is 0. So vy is equals to ev by md into d by u. Now if you remember in the parallel vector law, or the law of parallel vector addition in 11th grade, then here the velocity is equals to the root of the components, right? The vector resolution components, which is, well, u square plus ev by md into d square by u square. Sorry, this whole thing square. And also the angle is equals to tan inverse vy by vx. So therefore the angle of projection is tan inverse ev by md into d by u, which is just u square. This is it for the motion of electron in electric field. Remember that if it just grazes, then y is equals to distance by 2. If you learn something new, please like and subscribe. Thank you.